the numerator is negative, we only need to analyze the denominator. The sign changes here. From the left of -1 is negative, from the right of -1 is positive, because I have to plug in -0.9. -0.9 plus 1 is positive, but -1.1 plus 1 is negative. So negative over negative is positive infinity, negative over positive is negative infinity. Is that okay?
Yes, thank you.
Perfect, good. So now for the slant asymptote. So the slant asymptote is always the quotient of the division. What division? In this case, we have x squared minus 9 over x plus 1. Only the quotient. So when we divide x squared minus 9 over x plus 1, we will get a quotient plus a remainder over the divisor. So Q, quotient. R, remainder. D, divisor. Divisor. So divisor is x plus 1. Quotient we will determine, remainder we will determine. Why is the slant asymptote only the quotient? What happens to all this? Where is this going? Why the slant asymptote is only this? Because at infinity, you will see this will always go to 0. 0. That's the reason why the slant asymptote is always the quotient, and only the quotient. Okay, how do I determine the quotient? So we have two options. We have the long division, and we have the synthetic division. Which one do you want me to use? So the options are long division, division, and synthetic division. The synthetic division works because the denominator is x minus a number, like x plus 1, x minus 3, x plus 10. All these are in this form. The long division always works, but the synthetic division has limited applicability. Only if we have these types in the denominator, not 3x, not 4x, not x squared. They have to be of this form, like this. Let's do the synthetic division. So here's the synthetic division. In the box, I have to write a, but it's x minus a, which means a is -1. -1 will give us the 1. So I put in the box -1. Then the coefficients of the numerator. 1 is the coefficient of x squared, but the coefficient of x is 0. The coefficient of free term, I would say, better, is -9. We draw a horizontal line. We copy the first coefficient always copied, whatever it is. -1 times 1, we write above the line. We perform the operation 0 minus 1, -1. We continue, -1 times -1 is 1. We write above the line. -9 plus 1 is -8 when we always box in the last number. The last number is the remainder. This is this. This is -8. The divisor is x plus 1, and the quotient comes from here. Since I divided power 2 by power 1, this has to be power 1. So then x squared minus 9 over x plus 1 is x minus 1 minus 8 over x plus 1. This is the quotient. -8 is the remainder. X plus 1 is a divisor. Only this is the slant asymptote. Again, why? This piece is 8 over huge. At infinity, this will approach 0. This fraction will approach 0. That's why the slant asymptote is only the quotient. Okay, back to our table. We want to find the limit. The limit for the function is where the slant asymptote is going. So where is this going? It's a positive slope. It's going to negative infinity at negative infinity, and it's going to positive infinity at positive infinity. And that's what I know, and that's how I know that this must be negative infinity and this must be infinity. How do I know? From the slant asymptote. Because it has a positive leading coefficient, it looks like this. If it had a negative leading coefficient, it would have looked like this, from positive infinity to negative infinity. But it has a positive leading coefficient. So that's how I know. Okay. A lot of work for these functions, as you see. I'm done with this. Finally, done. Now I have to find the derivative. It's going to take me a while to find the derivative. It's going to take me even longer to find the second derivative. So that's why I will not put a function like this. It's way too long for a test or final exam. Okay, so here's the function, x squared minus 9 over x plus 1. It will take us a while to find the derivative. And it will take us even longer to find the second derivative. So, can anyone help with the first derivative? Anyone would like to help with the first derivative? First of all, which formula we apply here? What is it called?
Quotient rule.
Excellent. Thank you so much. We have to apply the quotient rule. Awesome. Can anyone differentiate the numerator? Excellent. Minus. Now I copy x squared minus 9. Can anyone differentiate the denominator for us? So I can put it here. Excellent. So I don't have to put anything. Good. Distribute. 2x squared plus 2x minus x squared plus 9. 2x squared plus 2x minus x squared, but plus 9 over x plus 1 squared. 2x squared minus x squared is x squared plus 2x plus 9 over x plus 1 squared. I have the first derivative. Awesome. Now, f prime of x is 0 or f prime of x is undefined. I need the critical numbers. So this is undefined at x equals negative 1, but so is the function. So it cannot be a critical number. Good. F prime of x being 0. What happens when I set this equal to 0? When is this fraction 0? Only when?
The zeros in a numerator.
Excellent. X squared plus 2x plus 9 equals 0. I can use the quadratic formula, or you are allowed to use, if your calculator has this feature, please use it. So, under apps, right here, go to number 9, polynomial root finder, yes. Degree 2, yes. First coefficient, 1. Second coefficient, 2. And the last coefficient, 9. Of course, this will have imaginary solutions, which means it's always positive, because the leading coefficient is positive. Imaginary solutions. Waste of time. That's why this is so quick. No solutions. So this is always positive. This is always positive. No critical numbers. What is the sign of the derivative always and forever? If the numerator is always positive and the denominator is always positive, sorry about that. What is the sign of the derivative. So I can put it in.
Positive.
Always positive. At least that. Good. Now, moment of truth. If these two rows have a hiccup, like they did, remember when I put negative 2/3 on the other side where we shouldn't be, then I'll say stop. Something is wrong. I have to start from scratch. So let's try. From negative infinity to 0, what does the function do?
Increase.
Excellent. From 0 to infinity, what does the function do?
Increase.
Excellent. Is that supported by the sign of the first derivative?
Yes.
Excellent. So far we are okay. From negative infinity to negative 9, what does the function do?
Increase.
Good. Is that supported by the sign of the first derivative?
Yes.
From negative 9 to 0 and then from 0 to infinity, is that supported by the sign of the derivative?
Yes.
Excellent. Now we're going to get a little headache to differentiate this. Let's give it a shot. Since we started, we have to dance all the way till the end. Have to square the denominator. Good. Can anyone differentiate the top? Anyone?
X plus 2
Very good. Times x.
times x plus 1 squared.
Excellent. Minus. I copy that. And now careful. Can anyone differentiate this piece?
We'll do 2 times x plus 1 and then
Times the inner function prime, which is?
1.
Excellent. Do not try to simplify in this form. Remember, that's not allowed. I have to factor out first. And I will factor out an x plus 1. So I took an x plus 1 from here, but now I have to distribute this. 2x times x, 2x times 1, 2 times x, I'm going to put 4 here because I run out of room, and 2 times 1. This is out. I have to distribute 2 with minus in front to these three terms. So negative 2x squared minus 4x minus 18. Now, only now, I lost who did I did, Marcy. Okay, so now I can do this. I remove the factor of x plus 1 from the top, and I remove the factor of x plus 1 from the denominator. Luckily, look at this. Awesome. Awesome. I love it. 2 minus 18, negative 16 over x plus 1 to the third. Unexpectedly beautiful. Okay, good. So now, where is this undefined? Who cares? The function doesn't exist there. So the second derivative is undefined at x equals negative 1. But so is the function. Can this be ever 0? Because that's the other option. F double prime being 0 or F double prime being undefined.
No.
No. Excellent. Now we have to study the sign because x plus 1 has power 3. It can be positive or negative. So please plug in negative 3 to the left of negative 1, negative 3 plus 1, and just give me the sign of this, just the sign. Negative 3 plus 1 is a negative number. To the third, negative number. The top is negative. What will be the sign? to the left of -1, and I will put it in.
Positive.
Yes, yes, thank you. Holds water. On the other side, let's plug in 0, the easiest one. 1 to the third, and the top is -16. I only need the sign.
Negative.
Negative, which means it doesn't hold water. I know it's silly, but you may remember it. This is it. And I have one more note to make to myself. Where was it? Y equals x minus 1. Y equals x minus 1 slant asymptote. Okay, everything else is gibberish now. I don't need anything. I don't care about anything. I don't want to see anything. Everything is in the way. It makes my life more difficult. I only need my table, nothing else. I don't need anything. I don't want to see anything. Everything bothers me because it's not relevant anymore. This is everything that I need. It's right in here. Okay. First, I have to graph the asymptotes. This function has two asymptotes. Has x minus 1 as slant, and it has x equals -1. This is first, -1. In order to graph this, I need, when x is 0, y is -1. When y is 0, x is 1. Y equals x minus 1. Now I will graph what I need to graph. From -infinity to -3, 0, -1, -2, -3. From -infinity, approaching the asymptote, crossing the x-axis at -3, 0, going to positive infinity, opening up at all times and increasing all times. Okay, fine. Opening up, coming from approaching the asymptote, going to approaching the asymptote, opening up, crossing it, -3, 0. This side of the asymptote is done. We're moving on to the other side of the vertical asymptote. From -infinity to 0, -9, 2, 3, 4, 5, 6, 7, 8, 9. From -infinity, crossing at 0, -9, crossing at 3, 0, always opening down, always increasing from -infinity, crossing, 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 approaching the asymptote at positive infinity. That's all I needed. So this is f of x. You chose a very nice function. So now, yes, I am going to share my screen, put it in the graphing calculator, in y equals clear and clear. The second function must be the slant asymptote. The function must be in parentheses as x squared minus 9 close divided by parentheses x plus 1. All these parentheses are mandatory. Now I will change the viewing window. I will want to go maybe to -15 to +15. I may have to adjust it later with a scale of 3, y minimum, I would choose the same thing, -15 to +15 with a scale of 3. And now I would like to graph. I know exactly how the graph should look like. When I press enter or graph, I know exactly what I'm going to see. Okay? The only thing that will be missing is x equals -1, the vertical asymptote. Here it is. From approaching the asymptote towards -infinity to approaching the vertical asymptote towards +infinity, from approaching the vertical asymptote towards -infinity, crossing at 0, -9, crossing at 3, 0, crossing at -3, 0, approaching closer, getting closer and closer, closer and closer to the slant asymptote towards infinity. So the only thing that is missing is the vertical asymptote, x equals -1. So this is it. And it took me, yes, I write extremely big so for you to see, but it took me several pages. From the very beginning, and so here's the beginning, then the limits, then the synthetic division, then the derivatives, then the table, then the graph. No, I'm not